Today I thought let's talk about scaling substreams. So last time we were talking about Firehose, we didn't talk too much about substreams, and in fact, the way to scale substreams has changed and been made easier, in the last year. So it's a good time to talk about it. All right, so just to bring back original architecture diagram of where Firehose fits in for anybody who's new to this. So we have our graph node that normally talks to archive node. And here we've introduced Firehose, which, needs some sort of Firehose enabled execution client, or there's this new mode actually where Firehose uses RPC calls. So it could actually use the same archive node. So this stuff on the right here is optional depending on what chain it is. But anyway, so let's just zoom in. And now we've got the details about all the Firehose components exploded out in the diagram. And for today, I'm not going to really focus on most of the components. I just want to focus on substreams parts. So if you have questions on the other parts, feel free to ask. But we're going to spend most of the time here on substreams tier 1 and substreams tier 2. Okay, so what are these two things? So substreams tier 1 is the end user facing component that's processing, live data. Let's just go back and look at the diagram here. So we can see substreams tier 1 is connected to the user. So the user can connect directly to substreams tier 1, or you can also see that graph node up here can connect to substreams tier 1. So if you've got a substream powered subgraph, graph node, if you configure substreams in your graph tunnel file, it can connect to substreams as well. So graph node can either read from an archive node doing RPC calls, it can read from Firehose, and it can read from substreams. So there's multiple ways of getting data into graph node. All right, so substreams tier 1, so it's end user facing or graph node facing if you like. You need one or more of these per chain. So the or more part is for scaling. So you need at least one per chain. So if you want us to do Ethereum substream powered subgraphs, you're going to need at least one substreams tier 1 node. Mostly when we've talked about Firehose in the past, we always just kind of gave one stack. Hey, you can run all those Firehose components that are on this diagram. Let's go back to the diagram here. So everything that's on the diagram, you could run in one binary. You can still do that. There's no problem. But today's presentation is about scaling. So scaling, you can't just scale one, right? If we're talking about scaling, we're talking about bringing substreams tier 1 and tier 2 to multiple machines. So specifically, we're talking about horizontal scaling. So horizontal scaling means scale it across multiple servers. All right, so that's the goal here today. So one or more, so you need at least one, and more depending if you got 1,000 substream powered subgraphs, you might need more than one substreams tier 2 node or tier 1 node. Maybe, I don't know what the number is before you need more than one. You have to look at your hardware. We'll talk more about that later. So it's according to the workload. And then if you have different chains that you want to support, you need a substreams tier 1 endpoint for each chain. Just like you need a Firehose for each chain. So you need a substreams for Ethereum, you need one for BSC, you need one for Polygon, etc. All right, and then you run the specific Firehose binary for the chain or Firehose core if, it's for Solana, for example. So hopefully that's clear. It's just the normal setup that you would normally do with the rest of the Firehose stack. Substreams tier 1 looks pretty much like that. And I have the config files later so we can look at them. Substreams up tier 2, on the other hand, is very different. So you can run it like substream tier 1, and you can tie one tier 2 node to each tier 1 if you want. However, that doesn't scale very well because the load that substreams needs to process, at one point it needs to process, you have a new subgraph on Ethereum, so it needs a bunch of tier 2 nodes to quickly process that. That catches up to live, and then those tier 2 nodes are kind of sitting there going, nothing to do, right? But then you start syncing a subgraph for BSC. Now those tier 2 nodes can be busy again. So if you have one pool of tier 2 nodes that can be shared now across Ethereum, BSC, Polygon, Solana, name whatever chain you want, you only need one cluster of tier 2 nodes. If you want one cluster per blockchain, go ahead. But The thing that's changed recently last year is that now you can create one tier 2 cluster and have it hooked up to all your tier 1s that you have, no matter what the blockchain, which makes it much easier from a scaling perspective. All right, so Substreams tier 2 is responsible really for processing the historical blocks, right? In a parallel mode, the jobs are split up and then we can process them, and it's blockchain agnostic, right? And here, interestingly, you actually run Firehose Ethereum on your tier 2. So if you want to share even for Solana or Bitcoin or Near or Arweave or any other non-Ethereum chain, you still use Firehose Ethereum. And the reason you do this is because Firehose Ethereum has the most features of all the blockchains. So with Firehose Ethereum, you can support any other blockchain. Okay, so the tier 2 always runs Firehose Ethereum. Okay, so for storage, previously when we've talked about Firehose, we've talked about, you can store your Firehose blocks locally on a local disk, or you can put them in an S3 bucket. If we're talking about scaling, really now you need to put them in an S3 bucket or some sort of object storage, because now you're going to have to share those Firehose blocks across multiple machines as your substream nodes scale across more machines. So internally, we use Ceph. Other people have used Seaweed FS. Your mileage may vary depending on what you try. Other people also store it in Google Cloud. That also works. You can store it in AWS. Those things are expensive, but try different things. If you want advice on what things to try, feel free to ask questions in the Discord channel. All right, so you need really some sort of object storage. If you want to drive yourself nuts, try not using object storage, right? That's the way to give yourself a nightmare. So for ease of use, figure out how to run an object storage solution and then store the data in an object storage. And I see Vince is sharing that Etzner also has object storage. Excellent. You can get object storage on DigitalOcean as well. DigitalOcean does use Ceph behind the scenes. So in addition to the Firehose blocks that you may already have, you do need some space to store the substreams cache. So substreams, when data gets processed, ideally you don't want to process it again if nothing changes. So all the results for all the substreams calculations are all stored on disk or in S3 storage. Or your object storage, right? So you need to space for this. You can clean up those cache files if, there's a subgraph you synced and, 6 months later, nobody's using that subgraph anymore. It's obsolete, whatever. Well, you can delete the cache files for that. But there is no automated out-of-box substream cache cleanup thing. So maybe we'll think about, how to build such a thing or tell you which things haven't been used recently. But there currently is nothing out of the box that comes with substreams to clean this up. This is kind of, you cleaned it up on your own. If you accidentally delete substreams caches that they're still needed, well, the system's just going to regenerate them again. Okay, and otherwise you don't need any local storage for substreams. So substreams doesn't need any local storage on your disk. It all just uses the object storage. So when it starts, it pulls Firehose blocks from the object storage, and then it writes substreams cache files back to the object storage. Any questions I need to address? Doesn't look like. Okay. Moving on. Okay, so we need to talk about the configuration. How do we go from tier 1 to tier 2? Let's just go back to the diagram here. Right, so we're going to talk about this little line here between tier 1 and tier 2. So that's the topic for the next few slides. Okay, so tier 1 needs to send the load to tier 2. Right, so if a user or a graph node connects in and says, please sync this substream powered subgraph, well, we need to split up the work into chunks and then ask the tier 2 nodes to please process the chunks. So the chunks are ranges of blocks and they're one or more substream modules. So let's talk about this for a little bit. So splitting things up by blocks makes sense, right? If you can, substreams are designed to run in parallel. So if you have, say, 100 substream tier 2 nodes, if you split your workload up into 100 chunks, each one can get one chunk at a time, and then they're all busy. Okay, it doesn't actually work like that. It actually splits it up into a block range. So like 1,000 blocks. So every time it processes 1,000 blocks, it gives out chunks of 1,000 blocks. And then when that chunk is done, then tier 2 says, I'm done. And then tier 1 will say, okay, here's the next chunk of 1,000 blocks you need to do. But it might not be the next chunk of 1,000 that you just finished because there's other tier 2 nodes busy. So it'll give you another chunk, right? So tier 2 nodes are stateless. They just receive a request for a job. They process the job. They write the data back to the S3 bucket, and then they say, ready, and then it waits for another job. Otherwise, they sit there and do nothing. All right, so chop it up into chunks of blocks, and then also substreams are composed of multiple modules. So substream module is something like, I need to read this data, then I need to read this other data, then I need to combine these two sets of data and produce another thing. So there's a ordered graph, if you like, of work that has dependencies. You can process this independently of that, and then you take those two results and then you combine them together to produce an output in a simple fashion. So a substream could just have one module, or it could have a bunch of modules. So the work needs to be split up according to the dependency tree graph. And sometimes you can run multiple dependencies together as a module, as a workload, and sometimes they get split up. Don't ask me the details on when it does what. It doesn't really matter. It's just about the work nodes need to be split by module and by block range. So the best way to kind of see what's going on is to actually just be a user and run the substreams GUI, and it will show you the workload and what it's processing. And then you get a good idea of kind of how it works. All right, so you can get a visual representation of what's going on by just substreams, a GUI, and then pass the subgraph QM hash, and then you can see it executed. It's IPFS : // QM whatever, and substreams will read the hash and process it for you. Okay, so tier 1 needs to split up the work and then send the work to the tier 2 nodes. Tier 2 nodes are stateless. They just get whatever the work they need to do, process it, write the results back to S3, and then they wait for the next thing. Tier 2 node can process multiple things at once. So it doesn't have to just do one, because maybe a tier 2 node is a machine with multiple CPUs in it. Well, you don't want to just use one CPU. You want to use a bunch, right? So tier 2 nodes can accept multiple jobs at once, and we'll see how to control that in a second. So the interesting thing is, you can imagine processing, the first set of blocks on Polygon. Those blocks are pretty empty, versus the last set of blocks on Polygon, which, are not empty. So each set of jobs, take more or less time depending on, what it needs to do. So each set of work is not equal. So it might need more RAM, might need less RAM, might need more CPU, less CPU. So basically, you can't just schedule tier 2, component 1 process job, then the second one, and third. You can't just go around. You need to actually look at the availability. Dear tier 2, are you available to process more work or not? And then send the load accordingly. So there's a couple of ways to do this. There's the gRPC discovery service. Then I gave you the command line option to configure that. You might use that in, say, Kubernetes. And the DNS health aware DNS. So if you have a DNS server that understands the state of whether the tier 2 can accept jobs or not, then the tier 1 can connect DNS and only get the DNS endpoints for the ones that are available. So that's the one I'm going to go through today, because that's the one I'm most familiar with and we use. All right, so let's just talk about it. So we're using Consul, which is an open source tool from HashiCorp. And the basic way it works here is if you do run this little curl command here, you can see I'm connecting. So localhost 9000 in this case is the substreams tier 2. So run this command on the substreams tier 2 node, and it returns, is it ready or not? So if the tier 2 node is overloaded, it will say, no, not ready, and you get a false. If it's ready for more jobs, it will return a true. So you can use this with a health check built into console to check whether you get a true or a false back, and then report that back to your DNS, and then DNS will add and remove that entry from DNS according to whether it's true or false. How does the tier 2 node determine it's overloaded? Okay, good question. It's on the next page. Okay, so in this case, I'm not going to go through how to configure console. The documentation for console is really, really good. You can figure it out yourself. In this case, you'll notice I use user bin check tier 2 HTTP health. This is just a little script that parses that JSON and returns an exit code of either 0 or 1 or 2. 0 being I'm available, 1 being maybe not, and 2 definitely not. Okay, so these are and that's how console knows whether the service is available or not. Okay. Okay, I lied. It's not on the next slide. It's on the next slide after. So I'm just showing a screenshot of what console looks like in our case. So you can see all the nodes here, and they're all healthy. If they were not healthy, then there would be a red X inside the console UI. Okay, so to answer Marc Andre's question, the line at the bottom, if this slide is that how this tier 2 know whether it's overloaded or not. So you tell the tier 2 node how many jobs you want to process in parallel. So in this case, I put 30. You can put whatever number you want there. And then whenever it gets to having 30 jobs that it's running, then it will change the health check back to false. The DNS will remove the endpoint from DNS, and then tier 1 will not send it jobs. If you put it too high, then obviously you're going to run a RAM or CPU. If you put it too low, then you're wasting hardware. So the challenge with configuring substreams is getting a feel for your hardware and the load that you have. What is the right number to put here? So you can fiddle around with how much RAM do you allocate to these things. So maybe, you don't have a machine with 128 gigs of RAM. So I only have one with 64. Well, maybe I'll only send it 12 jobs. Or maybe I have one with lots of CPU cores, right? So this way you can size the RAM, CPU, and the number of parallel requests. So each tier 2 node you can run on different hardware with a different number of concurrent requests it can handle. Yes, it will error out to answer the question. So if you try to send a job to the tier 2 and it's not available, it will error out. So if you don't want to do all this health checking stuff, you can just let it error out. And, eventually you might get the DNS for one of the tier 2s that actually works. And, that's fine. Otherwise, I do have a chart. What happens when you don't have it set up correctly? Okay, so add as much, depending on what machines you have available, add RAM or, CPUs or whatever. I'm just using the example that we have, but feel free to change it depending on what you have. And it really, really varies based on the subgraphs. So for example, there's a Bitcoin subgraph that somebody's doing ordinal processing. You need gobs and gobs of RAM for that one to work. So, this would not work, this configuration, 128 gigs of RAM with 30. So, but, for the average substream, this is going to be fine. It's probably overkill. You could probably bump it up more. But this is something you're going to have to try with your own experience. So you'll notice in the tier 2 here, there's no S3 buckets or anything else specified, because the tier 1 will pass the configuration for the specific chain to the tier 2. So remember, the tier 2 nodes are blockchain agnostic. Doesn't matter. They can process a Solana load and an Ethereum load and a Polygon load all at the same time. They count each as one of the 30 requests in this example. So it's not a problem. We don't actually specify the details of where to find the blocks or where to write the cache. It's not specified here. When tier 1 connects to tier 2, it tells it all that information. So it's passing the parameters from the tier 1 configuration to tier 2. The tier 2 knows how to interact with the storage. Okay, so tier 2 is not passing the results back to tier 1. Tier 2 is writing the results back to the storage and then tells tier 1 it's finished. and then it's ready to accept another job. So this is our configuration. It's very simple. Okay, and then just one warning here, don't expose the tier 2 nodes to public, right? Because, they accept configuration parameters, so you don't want to be exposing that to the public. Okay, so here's some monitoring slides from tier 2. For example, so the first 4 charts here at the top, these are coming from, the node monitoring. So I'm not using Firehose or Substreams to monitor this. This is just looking at the node exporter or the container advisor exporter that I've installed. So here we're receiving traffic into the Substreams tier 2 nodes at, 100 megabytes per second. I just happened to grab this screenshot, the other day when I was putting this slide presentation together. So it's reading the Firehose blocks at 100 megabytes per second, and then it's writing the Substream cache files at 100 megabytes per second. So there's an 8-to-1 ratio in this. The Firehose blocks are getting processed and then reduced down to a very small, 1/8 the size for the cache. And you can see we're using like 300 CPU cores and a terabyte of RAM or so. So it's busy doing a whole bunch of work here. I have no idea what it was doing at the time, but that's what's going on. But you can see here it's processing, 2,700 tier 2 requests at once. So there's a lot of parallel jobs that are running in this example. So when you're starting out, you don't need a terabyte of RAM. You can start with a lot less. And based on the amount of hardware you have, it'll process. That's how fast it will process the Substreams job. More hardware, it'll go faster. Less hardware, it'll go slower. It doesn't mean it won't work. It's just going to go slower. Okay, let's talk about tier 1, and then I'll show you the chart for the health check thing, that question you asked. Okay, so tier 1. So here's an example. In our setup for tier 1s, we actually run multiple tier 1s on the same server with overlapping RAM, if that makes sense. So the server has 128 gigs of RAM. We've allocated 25 gigs of RAM to this tier 1 node, but there's like 20 tier 1 nodes. So if you do the math, 25 times 20 doesn't fit in 120 gigs of RAM. So, because it depends how busy it is. So we've taken if it's too busy, then the whole machine will crash. But on average, we don't have that much load going from one to another. So again, scale it according to the load you have. Maybe you can work with less RAM. Maybe 10 gigs is enough. Maybe less cores, more core. Anyway, scale this according to your load in terms of how much to allocate to Substreams. Okay, so here we've got a much bigger configuration file. And as I said, this configuration is going to be passed to the Substreams tier 2 node. So then it knows where the S3 buckets are. So in here, we're reading the relayer. We're also using console for publishing where the relayers are available. Merge block, one block, fork blocks. There's S3 buckets for that. Substream state store. So this is the cache files for Substreams. And then the last line is hey, where is the tier 2 nodes? So Substreams tier 2 v1 service console. So we're always using port 9000. Obviously, you guys don't need to use port 9000. That's just how we have things set up in our environment. So we're always overriding that, but it's not necessary. So just make sure the Substreams tier 1 is pointed at wherever the DNS is for your tier 2. Right, so this Substreams tier 2 DNS entry will only return results for the ones that are healthy. If they're not healthy, it does not appear in the answer here. If none of them are healthy, you get no answer, right? Nothing's available. Okay, so here's the monitoring stack for tier 1. So same sort. This is looking at Ethereum. So remember, the tier 2 was generic, right? It's processing all the blockchains that we support, whereas this is just Ethereum, right? So I've got the same set of charts for every single blockchain, but the tier 1s are all separate, where the tier 2s are combined. All right, so here we're processing, network traffic in, out, how many CPU cores. So here it's running 142 requests, in 2.5 CPU cores, right? So maybe you don't need 4 CPU cores, it's too much. All right, so memory usage. So here it's using 40 gigs of RAM, and it's sending out a 2500 worker requests. So this is how many requests that are active in the tier 2. And the last chart is the how many rejected ones. So the tier 2s are returning the "I'm busy, go away" messages, so you can keep track of how often that happens. So for example, in our case, if the health check only runs every 5 seconds, there may be a period of time where the tier 2 node is busy, but the DNS is still returned as valid. And then in this case, we're catching this. So you can monitor the overloaded situation here. Okay. Monitoring and logging. Pretty much you want to be using Prometheus and Grafana to understand what's happening. So Substreams tier 1, Substreams tier 2, just like Firehose exports a whole bunch of metrics. You can have a look at them. I put an example one here. Substreams tier 1 active worker requests, which is one of the charts that we showed. You will need to add your own labeling into Prometheus so you can see which network is which. So that's a Prometheus feature. And then I really recommend putting logs into a central logging system. So if you're trying to find out why some substream fails or whatever, you're not looking at all the logs from every single tier 2 node. Really, if you can put all those logs for all the tier 2 nodes in one place, it's going to make your life easier. So I recommend thinking about that. All right. Last slide I have here. So the sizing numbers I have are just to get you started. It's going to be based on your experience, your hardware, your subgraphs you're running, whatever. So this is not a, just set something and forget it. You're going to have to look at those metrics to understand if you're over provisioning hardware too much and what the situation is. If you want advice in certain situations, feel free to ask in Discord. I can definitely try to help you, but it's more of an art than a science in terms of configuring the load here. And it also depends. For example, we're using HDD storage. So our Ceph server is on HDDs. So HDD storage is what? Slow. So for example, when a tier 2 node gets a workload from the tier 1, there may be a slight delay there before it can start working on stuff because it has to wait for the storage coming from the S3 bucket for the hard disk to send it. And same with writing it's writing it back, right? So, the tier 2 nodes spend a bit of idle time while it's waiting for the storage. If you got really fast storage, that idle time goes away. So you would, maybe can spin up less tier 2 nodes because you don't have to account for that idle time, right? So it's gonna really depend on how you have things set up. As I mentioned before, some substreams are quite complex and take a lot of CPU. Some are very simple. Maybe they have tons of modules or they only have one module. So the actual load for one substream to an next is going to be quite different. Also, some do a lot of ETH calls, which means your tier 2 node is waiting on your RPC node to answer, right? So they might be sitting there idle because you've overloaded your archive node that answering ETH calls. So as you scale up your tier 2 nodes, you may need to also scale up your archive node if you want to run a lot of tier 2s in parallel and you're doing a lot of ETH calls. Again, depends on the subgraph. Some do a lot, some don't. As I said, we've opted for HDD storage and we've also opted for older CPUs because they're more affordable. So we put lots of CPUs and RAM and we scale. So for substreams, you don't need the biggest, fastest, best machine. You just need a lot of CPUs if you want to do things fast, and you don't have to choose the best and fastest one. Go find your favorite used hardware reseller and, ask them for hardware. That will work perfectly fine for substreams. from a scaling perspective, ideally you would want to put this in Kubernetes so that the tier 2s can scale up and down. But if you don't have Kubernetes and you're willing to allocate hardware just for tier 2s, you can do that too. Currently, that's what we do. We're moving towards Kubernetes. We've done a couple of presentations on Kubernetes. We're going to move our substreams into Kubernetes, but the current deployment that we have is actually not using Kubernetes. So it's using the Matthew scaler, right? So whenever I see there's extra load, then I need to shuffle it around. And just to note, the substreams does not use the Firehose search index. So it's only used for Graph node when it's connected to Firehose. It's not used in substreams. Okay. A support Discord link. So that's the normal, Graph protocol / indexer Firehose, I guess. That's the best place to ask questions. Great tier 2 nodes. Yeah, I don't know what you got there. I'm trying, the picture's small, but yeah. Find, slightly older hardware, as it doesn't need any local disks. So like a 1U machine or a Blade Center, any of those will work. All right, that's it. Any other questions? How many substream powered subgraphs are out there? Good question. I do not know off the top of my head. Is that a question we can ask the network subgraph? We should be able to, I guess. Maybe not. With curation 5 or 6. Okay, so not too many yet. But there are more substream power subgraphs that are kind of not on the network yet, or they're not available for indexing rewards. There's definitely a whole bunch there. And obviously you can use substreams for other reasons other than network substream powered subgraphs. If you're trying to build some other tooling or use it for other purposes, it's not required to just use it for substream powered subgraphs. Yeah, substreams will write into a webhook or a Discord channel or a Postgres database or ClickHouse or something, and then you can use that to do analytics or whatever else if you don't want to use subgraphs. Yes, I will make the presentation public. I'll post the link in the Indexer Firehose channel after. I think that was, not a question. So Firehose and substreams coming to the network as first-class data services, according to Chris. So that sounds exciting. Yara asks, do I ever delete the old substreams cache? Yes, I do. I wrote the script and I think I used like 30 days, something like that. If a new cache file has not been written in at least 30 days for a substream, then I delete it. I delete the entire cache for that substream. So the cache files are organized by module ID. So if you do substreams info on a substream or a subgraph, it will give you the module hashes, and then the cache files are organized. There's one directory per cache. So a single substream may have multiple modules, so you may have multiple cache files depending on the thing. And then the files are named after the block number. So you can see, and if you look at the dates on them, you'll see when they were written. So that's how we do it. I think Streaming Fast has a more advanced system where they're writing cache information into a database. I'm sure we'll work on something that allows people to clean things up easier in the future, but yeah, currently there's no auto cleanup, so you need to write a little script yourself. If you want advice, feel free to ask when you get to that point. Happy to share. Well, Yarrow, you can write a UI. There you go. Project for you. Nice weekend project. This is what happens when engineers in my team ask questions. They get assigned work. Good idea. You should work on that. Good question from Vince here. When you need to roll back Firehose, what work needs to be done? Okay, great question. I probably should have put a slide on this. I did not. All right. So on occasion, some blockchains have weird things happen where you need to roll back blocks because I don't know, they're doing weird stuff. Right? Normally you would consider a finalized block is a finalized block. That's the whole point. Right? But we have seen some chains in the past where that is not the case. So in this situation, you actually need to remove Firehose blocks. You're going to need to remove substring cache files. You're going to have to let that replay, and then you're going to have to rewind your subgraph. Right? So because finalized blocks are supposed to be finalized, there isn't an automated way to recover when they're not finalized. So yeah, so you do need to remove merge block files from Firehose, remove substring cache files. Again, the substring cache files are by block number. So you can easily find, which ones you need to remove. You don't have to delete the entire cache for the one substring. So you can just remove the ones you need and then let it catch up and then rewind subgraphs. There is another situation where occasionally we find a bug inside substreams and you do need to delete cache files that are impacted by that bug. So we've had that problem before. Substreams does, I didn't put it in here, but there is a versioning field. So if you want, you can increase the version number and then Substreams will write the new cache files in a new directory for you. And then you can delete the old ones. So one of the things to consider in this scenario where you're doing recovery is typically you don't want all your subgraphs to start failing, waiting for substream cache files to get regenerated, blah, 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 blah. So you do want to come up with an off stream process to generate all those files, do whatever you need, and then kind of switch the live system over to the new stuff. So that's kind of a really advanced topic. Happy to chat with people if you want, but yeah, I didn't cover any slides on that. So yeah, a few scenarios. If the chain goes backwards, you do need to manually clean up according to the chain rollback. And then if there's a bug, if there's a bug in substreams where some cache files need to be cleaned up, there's also a strategy for that. So a few things that are still quite manual, as well as manually cleaning up substream cache files when they're no longer used. So as I said, we'll probably do some work improving this, but it is manual at this point. If in doubt and you don't care about reusing CPU, delete all your cache files and let them regenerate. That's the simple solution, but obviously not very efficient.